Hi guys. So I want to talk first about the unit circle today. I just want to bring your memory back. Remember that a unit circle has a radius of 1, and if we drop this perpendicular down to the x-axis, remember that makes a right angle, we know that the length of this side is y because it's the height, and the length of this side here is x because it's how far along the x-axis that our particle has moved. So the coordinates of this point here are x, y, and we talked in the past how that coordinate can be rewritten as cosine theta, sine theta. And that's because if theta is this angle here, cosine is the adjacent, x over 1, so cosine theta is x. Sine is the opposite, y over 1, so sine theta is just y. But if we go back to the geometry that we learned way back when we have this right triangle, we know that the leg squared plus the leg squared equals 1. That's the Pythagorean theorem, right? So now we're going to take this basic Pythagorean theorem and put it together with our trig, because we know that x is cosine. So this part becomes, instead of x squared, cosine squared of theta, plus we know that this piece y is sine theta, so this becomes sine squared theta equals 1. And now we have what's known as the Pythagorean identity, or one of the Pythagorean identities. And it's the most basic of the three. This is the first of the three Pythagorean identities. So I'm going to come over here, and this is the first of our Pythagorean identities right here. That's the first one that we just developed using our unit circle. Now, what I want to do is use that same formula, that same Pythagorean identity. I've written it right here. But what I'm going to do is I'm going to divide each part by cosine squared theta. I can do anything I want to an equation as long as I do it to everything, right? So I'm going to divide everything by cosine squared theta, and the equation is still balanced. Well, sine over cosine is tangent, so sine squared theta divided by cosine squared theta is tan squared theta, plus cosine squared theta divided by cosine squared theta is 1. And 1 over cosine squared theta, well, 1 over cosine is secant, so 1 over cosine squared theta is secant squared theta. And now you have the second of the Pythagorean identities. Now I'm going to go back to that first identity again, right here. I've rewritten it one more time. Sine squared theta plus cosine squared theta equals 1. Now I'm going to divide everything by sine squared theta. And when I do that, sine squared theta divided by sine squared theta is 1. Cosine divided by sine is cotangent. So cosine squared theta over sine squared theta is cotan squared theta. And 1 over sine squared theta would be cosecant squared of theta. And here is the third of your Pythagorean identities. So there are 3 identities that we'll be using. Okay, and they all come from that first one. So you will have a choice because you need to know these Pythagorean identities. Now you can choose to memorize all 3 of them, or you can choose to memorize the first one and then know how to find the other 2. Divide everything by cosine squared theta, you'll get the second one. Divide everything by sine squared theta, you'll get the third one. That's up to you whether you choose to memorize all 3 or if you choose to memorize one and know how to get the other 2. But that said, we don't always use the identities when they're in that form. For instance, if we know that sine squared theta plus cosine squared theta is 1, what would sine squared theta be? Well, in this equation, we would have to subtract the cosine squared theta from both sides, and we would have 1 minus cosine squared theta. Similarly, if we wanted to solve for cosine squared theta, we would subtract sine squared theta from both sides. So that first identity can be transformed into 2 more. that sine squared theta is 1 minus cosine squared theta, and cosine squared theta is 1 minus sine squared theta. Same type of trick. If we look at the second Pythagorean identity, okay, tan squared theta plus 1 equals secant squared theta. If I want to solve this for tan squared theta, I subtract 1 from both sides and get secant squared theta minus 1. If I have the identity 1 plus cotan squared theta equals cosecant squared theta, and I want to solve for cotan squared theta, again, I subtract 1 from both sides, and I have cosecant squared theta minus 1. So these are also identities that we have to keep in mind, okay? Now, not only that, there are some more identities that you may have seen hiding up there, the double angles, okay? These will actually be given to you on a formula sheet, okay? These will be given to you on a formula sheet. We will not ask you to memorize these yet, all right? And that says if you have the sine of 2 times an angle, that's the same as 2 sine theta cosine theta. Notice cosine of 2 theta has 3 possible identities. You could rewrite it as cosine squared theta minus sine squared theta, or you could rewrite it as 2 cosine squared theta minus 1, or you could write it 1 minus 2 sine squared theta. A little tricky because sometimes one form is easier to use than the other. Sometimes it doesn't matter. We'll talk more about that as we get into using these identities when one is better than the other, okay? But it also means that there may be more than one way to simplify something or to follow through on a problem. Also, you have there tan of 2 theta, that's 2 tan theta over 1 minus tan squared theta. You don't really have to use that one if you already have the rules for sine 2 theta and cosine 2 theta. You can use that instead. It's up to you. Remember, there's how many ways to get from where you are to the mall? Lots of different ways. Okay, as long as it's a valid path, doesn't matter. So the first thing we're going to do is we're going to simplify. We are going to express in simplest form. So we have 2 minus 2 sine squared x all over cosine x. And I'm going to start up by saying with all of these problems, there's often more than one way to approach the problem. So please don't get upset if I do it differently than you would have thought. Just because I do it differently doesn't mean your method is necessarily incorrect. All right, so when I'm looking at this, I look at that numerator and I see a common 2. I'm going to factor that out. And I have 1 minus sine squared x all over cosine x. Now, I notice I've got sines in the top and cosine in the bottom. I want to be able to have one trig function. And if I look carefully, this 1 minus sine squared x, so if I look at my identities over here, we've got this Pythagorean identity that has sine squared and cosine squared. Now we've got this 1 minus sine squared, and I can get that if I subtract sine squared from both sides. So that means 1 minus sine squared theta is cosine squared theta. Now I would have to be careful in this problem because I don't have a theta. I have x, so it's cosine squared x, but I also have to remember I had a 2, and this is over cosine x. Now this is something I can simplify, because cosine x goes into cosine x goes into cosine x once, and into cosine squared x, cosine x times, and we're left with 2 times the cosine of x. And that's about as simple as that's going to get. The next one, you say, okay, I've got cosecant squared x minus 1 over cosecant x minus 1. Now, do me a favor, don't write yet. Because if you try to use the identity that's got cosecant squared here, right? If I was to subtract the 1 so that I had cosecant squared x minus 1, that would be equal to cotangent squared x. If I put this identity and I substitute in here, I would have cotangent squared x over cosecant x minus 1. That's not going to help me. I now have 2 different trig functions. I've actually made this more complicated. So using this identity did not help me. It's actually making the problem more difficult. I'm going to go back and I'm going to look again. I'm going to say, oh, wait a minute. I can factor that top. That numerator is a difference of 2 squares. Cosecant x times cosecant x would give us cosecant x squared x. And if I add 1 and subtract 1, now I have that factored. And in the bottom, I keep that. And now I have an exact match that cancels out. And we're left with cosecant x plus 1. So the takeaway here is you don't always have to use an identity. Sometimes factoring is the simplest. You want to try to have as few trig functions as possible. Okay, so if you already only have one trig function involved, don't introduce a new one. Okay, try to use as few trig functions as possible. Let's try another. So here we have the sine of 2 theta over 1 plus the cosine of 2 theta. Notice I have sines and cosines, and both of them are double angles. So the top, there's only one identity for the sine of 2 theta. The sine of 2 theta is 2 sine theta times cosine theta. Now we have options for what to do here with the denominator. I can't just cross out the cosine 2 thetas, even if that 1 plus wasn't there, because cosine theta is different than cosine 2 theta and they don't cancel. I need to use one of these two identities, okay? And it's up to you which one you use. Some are easier than others. Some may, some will take longer to simplify, others won't. And it's really, what do you see first, okay? There is definitely more than one way to approach this problem. So please don't be frightened by that. Now, what am I going to use? You know what? I'm going to use the middle one. I tend to use that one a lot. That the cosine of 2 theta is 2 cosine squared theta minus 1. Now, notice I didn't want to use the first because it's got cosine squareds and sine squareds. And there's a subtraction between them. That's going to make it hard to cancel out with the top. So that leaves me the second and the third. The third one gives me a negative 2 sine squared. So rather than, I just don't like negatives, so I picked the middle one. It really does not matter, okay? They will both work. Now if I go through, this is 2 sine theta times cosine theta, and in the bottom, this 1 and this negative 1 are going to cancel, are going to add to 0, and I'm going to have 2 cosine squared theta. Now my 2's are going to divide to 1, and my cosine theta in the top is going to cancel out one of my cosines in the bottom, and I'm going to be left with sine theta over cosine theta. Almost done, because what do we call sine theta over cosine theta? That's just tan theta. And there we go. That's one way to simplify this. Okay, the next type of problem I want to look at is where you're asked to prove the trig identities. Now, some of you see this and you go, oh my gosh, I can't do this. I hate proofs. This is not like your geometry proofs. Please don't panic, okay? When you're given these trig identity proofs, what you're going to do, you're going to draw a line down from the equal sign. And the idea is to simplify the left and the right-hand side of the equal sign until they look exactly the same. Now, if you notice, this right-hand side, that's not getting any simpler. 2 times sine theta. You cannot simplify sine theta any more than that. That right-hand side is as simple as it's going to get. So we're going to look at this left-hand side, and we're going to try to simplify it and make it look like 2 sine theta. So sine 2 theta, there's an identity for that. Sine of 2 theta is 2 sine theta cosine theta times, now secant theta, that's one of our reciprocal functions, that's 1 over cosine theta. Now if I try to multiply these, what happens to the cosines? They divide out, and we're just left with 2 sine theta. Guess what? That matches the other side. We're done. You just did a proof. You proved the trig identity. That's it. That's all that's involved. You did it. Let's try one more so that nobody's too freaked out over these. So here we have sine 2 theta over 1 plus cosine 2 theta equals tan theta. So I'm going to draw my line down the middle. And it doesn't really matter which side you start with. I like to look at which side is the simplest. In the previous one, the simplest side was 2 sine theta, so I knew that's what I was going to head to. Tan theta, I can rewrite that as sine theta over cosine theta, and that's about as simple as it can get. So now my goal is to make the left-hand side look like that. Can I simplify the left-hand side to make it look like sine theta over cosine theta? Well, here we go. Sine 2 theta is the numerator, and there's an identity for that. 2 sine theta cosine theta all over 1 plus. Now I'm going to take this cosine 2 theta, and we get to pick one of these three again. I'm going to pick the middle one again. I told you I tend to use that one more. 2 cosine squared theta minus 1. So on the top, I've got 2 sine theta cosine theta. On the bottom, my 1's here, 1 minus 1, they're going to add to 0. And I'm just going to have 2 cosine squared theta in the denominator. My 2's are going to divide to 1. My cosine theta is going to cancel out one of them in the bottom. And I have sine theta over cosine theta. They're the same. I'm done. We did the proof. Okay, guys. So there you have it. You need to know your Pythagorean identities, at least memorize the first and know how to find the other two. You need to be able to use the double angle identities. So have them in a place where you can open it and have it nice and easy. All right, guys, have a good day.